Hi there. So we're on section 6.6, standard normal z. Z. All the statisticians love z. So z is a normal curve that is standard normal, so that means it has a mean of 0 and a standard deviation of 1. Let's go to our pretty paint picture. So here's the pretty paint picture. Let me get a fatty, that'll work. So for the z curve, this mean right here, that is 0. Right there. 0. And each standard deviation, each one of these little hops right there is 1. So that's 1, 2, 3, and -1, -2, -3. This is why we love the z curve, because everything is so clean and easy. Well, but you still need to figure out how to use probabilities and find them for the z curve. So for this video, I'm going to show you how to find these probabilities using the z tables, which are in your book. And on a test, I'm happy to give you z tables. So you have the choice of using z tables or your calculator. The calculator will be the next video. So using the tables, find the probability that z is less than 2.62. I just made up that number. It could be any number. So on our picture, so 2.62 would be about what here? 2.6, a little bit like there. Okay, I'm going to draw a little thing here, right there. 2.62. So you can see visually that 2.62, it's probably going to be a lot of probability. So 2.62 is right about there. And we want, if you look at the problem again, we want the probability that z, it's standard normal, it's not x anymore, is less than 2.62. That's going to be this whole area. I'll make it yellow. Let's start with yellow. There. That's that whole area. Everything from 2.62 on down. So the first way to do it is to use these z tables. So here is a z table. I copied this one. This is just a photo taken of the tables in your book. So I apologize for how hard it is to read it. My intention is that you look at your tables in the book and follow along with what I'm doing. So this is table C. It starts negative. You'll notice it starts on the negative side and then it goes all the way up. So I want, if I go to my picture, 2.62, probability that z is less than positive 2.62. So I'm looking at these numbers and I have to go to the next page. Here's 2, see how it goes 2.0, 2.5, 2.6, but I want 2.62. So I have to go over this part right here is the second digit. So I go 2.6 and then I go 2 over right there. So the answer is 0.9956. Do you see it right there? I'm going to circle it, 9956. I can't draw on this PDF with a great ease. So 2.6. 2 is right there, 0.9956. So the answer equals 0.9956. Great. That was the first problem. Let's look at the next one. Find the probability that z is greater than 2.62. Sometimes you get these problems. You'll notice the only difference is the way the Pac-Man, the arrow is facing. So now we want greater than 2.62. It's the other side, right? It's this side. Make my color black. I want that part right there. That part. Probability that z is greater than 2.62. The reason I put this problem in there is that the table, this table, always gives you the less than area. It gives you the area to the left. So if you want the area to the right, if we want this part of it, we have to subtract. So we use our complement rule. 1 minus 0.9956 equals brilliantly 0.0044. Oops, 4. 0044. So I'm saying, I'll try to fill that in for you guys. I don't think it's going to be a very impressive. That, come on, that right there. Oops, no, that didn't work. I got too much fill. Anyway, that little area right there is 0.0044. Right there, right there. I'll fill it with my little finger. There, my little pen finger. That area is 0.0044. Okay, next problem. Find the probability that z is between minus 2.62 and 2.62. So now we're doing 2. It's between two numbers, and I just picked the same so that I could remember them while I was going back and forth. Minus 2.62 and positive 2.62. So now I want the probability, here I'll write it down, minus 2.62, z, we're not dealing with x's, we have z, and 2.62. There we go. And on the chart, you'll say minus 2.62 is down here, minus 2.62, and now I want everything in between these two areas, okay, but not including the tails. I want to subtract the tails. So the way you do these problems is you think the book gives you everything from here, excuse me, when I say the book, I mean the table, everything on back. So we take the probability that z is less than 2.62, that's this whole yellow area, right? And subtract, we want to cut off, because I want the area in between, we want to cut off this little tail. So this little tail right there, that part, we don't want to include that part because we just want the in-between area. We don't want to include this little tail. So we subtract the probability that z is less than minus 2.62. So again, you can look up to your table. You can see this from the picture. So some of you are like, it's right there on the picture. That's fine. You don't have to look it up on the table. But if you didn't know, you could say, well, minus 2.62. So you start on this side, minus 2. I don't know what that little thing is. Hey, 2.6. And then you go over to 2. See, 2.62. That would be 2.63. Minus 2.62. That's 0.004. Minus 2.62. 0.044. So what this means is this area here is 0.0044. You could have seen that because it's symmetric, and you could have seen it on that side too. So now we know that the probability of the area in the middle is going to be equal to 0.9956, this whole area from there all the way back, minus that little tail, 0.0044, which equals, I believe, I'm going to go with 9912. So the answer to that one here would be equal 0.9912. And sometimes if you see these in the back of your book, it's not totally clear where that number comes from. Well, it comes from a beautiful picture like this. And I find it's easiest to do these problems by drawing a picture for each one until you get the hang of it. And then we have one more problem. Find the 60th percentile. So sometimes in the lecture notes, I talk about looking inside the table. I'm going to draw a new picture though. Hold on. Question says, find the 60th percentile of z. So 60th percentile, here's our standard normal z, right, there's 0, and we want the 60th percentile. So we want some number such that the whole area under the curve is 60% from everything on down. So I know it's going to be on this side because this area is only 50%, so I'm just going to, eyeball it, and maybe say, I don't know, like maybe here. I'm going to draw a line so I can fill it in better. I'm guessing. Am I going to be right? Is it going to be greater than 1? Everyone wants to know. We'll do orange. Orange. Fill her up with orange. There we go. So this, what we're looking for, is what is this number here? What is this number such that the probability that z is less than what? What number is equal to 0.60? Okay, so looking on the tables, how to do this on the tables. So we have the probability and we're looking for the number. So we're doing everything backwards from what we did before. So again, this is a probability. Probabilities are inside the table. So here's the table. Everything in here is a probability. And we're looking for 0.6. So we just keep going up. So you see how these numbers are 0.37, 4, 47, getting up to 50, because it's the middle of the table. So 0.6, okay, it's 50, it starts at 50%, at 0, goes up. Do you see how that's 0.5987 and 0.6026? So 60% is right between these two numbers, and so that's 0.25 and 0.26. Do you see that? That's right there is 60%, and we go backwards. So it's 0.2, and then you get the 5, or 0.26. You're going to have to look at your table and find it with your own finger, I think, to have this make sense. 0.25 or 0.26. So if we go back to our picture, we're saying this number here is about 0.25, between 0.25 or 0.26. And some of you might be really stressed out and think, well, isn't it right between them? Sure, that's fine. It can be 0.255, but really 0.25 or 0.26 would be fine for a problem like this. So to answer the question, find the 60th percentile, 0.25 or 0.26. And again, what that's saying is that the probability that z is less than we'll say 255 for you people that are worried about it being right in between, is equal to about 60%. So that's roughly the 60th percentile. So I'm going to do another video next where I do all of these same probabilities using your calculator, and that's ultimately how most of the students do it. Most students don't use the tables at all, they just go right to the calculator. So that's always a choice for you because you are clever enough to buy a calculator. Coming up next.